Hello again everyone and welcome to today's maths session. Now I know lots of you have already been getting really involved in your measuring. I've seen people measuring cupboards and tables and chairs and things and all sorts of probably valuable objects in mum and dad's house, but I'm really glad we're getting involved in our measuring here and we're practicing this skill. So here is a quick starter to get you going then. So have a quick look at this and pause the video, give these questions a go, see what you can remember and what you already know. Okay, so here then we've got how many centimetres are there in 1 metre? Well, you might remember that part of the word cent there means 100, so centimetres, there are 100 of those in 1 metre. How many centimetres are there in half a metre then? Well, we know that half of 100 is 50, so half a metre is 50 centimetres. How long is this line then? We've got really good at measuring on a ruler. That is 11 centimetres. And what about this line here then? I wonder how accurate you can be. Bit of a tricky one. I'll accept a good range here. What have you got? We can see it's more than 90, but less than 100. We can probably say actually it's more than 95 because it's gone past that halfway point between 90 and 100. So maybe you've got something like that. I'd say if you've got 96, 97, 98, 99, or even 100, I would say that's accurate enough. Don't worry if you were a little bit out there. So yeah, roughly 98 millimeters, give or take a few. So we're going to be thinking today about measuring lengths in meters. Now it does mention in a few of today's questions a meter ruler or a meter stick, which obviously we've got loads of in class. You're probably less likely to have at home, but it might be that you've got a ruler. It might be that you can use maybe mum or dad's measuring tape from a toolbox or something. But actually, even if you've just got a small ruler, even one of those ones that you could have printed off earlier in the week, actually you can make that work. You might need to sort of use a little marker and then sort of double it up a few times, but you can do it. It might just take you a little bit longer. So I'm sorry about that if that is a problem. So here we've got Annie, and Annie is comparing lengths to 1 meter. So lucky Annie, she does have a meter stick, you may not. So she's comparing this table to her meter stick. Now, is the table therefore longer than or shorter than 1 meter? We can say it must be longer than 1 meter because that meter stick doesn't quite reach the end. So we know that that table is longer than 1 meter. And you might even be able to estimate that if you were kind of comparing the table to a meter stick, particularly if you've got it there in front of you. Often you can do a bit of estimating, which means having your kind of educated guess. So Annie's continuing to compare lengths to 1 meter, and she's comparing her doll's house to this meter stick here. So we can see that this doll's house is definitely less than a meter. I wonder if we can work out how tall it is. Let's try to see how many divisions there are on that meter stick. And what I mean by that is how many different sections it's split up into. Shall we count them? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this meter stick, which we know is 100 centimeters, is split into 10 different sections. So how long is each section then? 100 centimeters split into 10 sections. We know each one is going to be 10 centimeters long, don't we? So how tall then is Annie's house? It's 60 centimeters, isn't it? We can count up our divisions here. We've got 1, 2, 3, 4, 5, and 6. It's 6 of these sections, so we know it's going to be 60 centimeters tall. Annie makes a table to show her results. And she's got some things that she's putting in the shorter than 1 meter category, and some things she's putting in the longer than 1 meter category. Important to note that it's a doll's house here, isn't it? So it'd be much taller than 1 meter. Her doll's house, shorter than 1 meter, her table, longer than 1 meter. The children are measuring Mr. Rose, lucky Mr. Rose. Do you know what? I think before very long, I'm going to have hair like Mr. Rose. Working with children, you see, I'm going to be going bald before very long, I think. It's all the stress. So here's Mr. Rose. The hair's certainly not adding any height to his measure here, is it? So how tall is Mr. Rose? Is he longer than or shorter than 1 meter? We can see he's longer than 1 meter. Is he taller or shorter than 2 meters? It's less than 2. Is he taller or shorter than 1.5 meters? What do you think? We can see the 1.5 meter mark would be here. So we know he's taller than 1.5 meters. Can we be even more accurate than that though, I wonder? So same again, let's count up how many little divisions there are between 1 meter and 2 meters. Let's count. So it's 1, 2, 3, 4, 5, that's halfway, 6, 7, 8, 9, 10. So again, we can see that 1 meter is split up into 10 different sections. Let's count how many sections it is until this dotted yellow line here, which is as tall as Mr. Rose. 1, 2, 3, 4, 5, 6, 7. So it's 7 of these little sections. And we worked out last time, didn't we, that each section is going to be worth 10 centimeters here. If we're splitting 1 meter or 100 centimeters into 10 sections, each one's going to be worth 10 centimeters. So let's count up in tens. 10, 20, 30, 40, 50, 60, 70. So we can say then that Mr. Rose is 1 meter and 70 centimeters. Ron and Amir have been measuring their arm span. Here is part of a tape measure. Now, we're only seeing a little bit of it here. What section are we looking at? We can see a couple of values. We haven't got the whole thing, but we can see a couple of values. We can see that we've got 1 meter here and 10 centimeters here. Now, that might seem like a bit of a weird gap. It's not going to be 1 meter and then just 10 centimeters on its own. I think this is telling us that it's 1 meter, and then here it's 1 meter and 10 centimeters. So this is a continuous line here, and it's going past 1 meter and then reaching 10 centimeters here. So Ron's arm span is here. Can we try to say how long Ron's arm span is then? It's greater than 1 meter, but it's not quite as much as 1 meter and 10 centimeters. Is it more than or less than 1 meter and 5 centimeters, which is going to be this halfway point? We can see it's less. So it's less than 1 meter and 5 centimeters. Shall we see what these divisions are, or how big these divisions are then? So we've got 1, 2, 3, 4, 5. That's up to 5 centimeters. So we can see that each of these divisions is worth 1 centimeter on its own. So how long is Ron's arm span then? What do you think? His arm span is 1 meter and 4 centimeters. It's an extra 4 we've gone along there. Amir's arm span is longer than Ron's. His ends up here. What do you think Amir's arm span is? Have a chat at home, pause the video. What is Amir's arm span? So his has gone beyond 1 meter and 10 centimeters. And we've already worked out that each little notch on here is an extra centimeter. So we've got here 10, 11, 12, 13. So it's going to be 1 meter and 13 centimeters. Ron and Amir decide to measure the length and width of the classroom. And you're going to be asked today to measure the length and width of a room. Obviously, yours won't be the classroom, but you could use your bathroom, you could use your kitchen, you could use your lounge, anywhere where mum and dad aren't working. So they want to measure the length and the width. Altogether, they measure 12 meters. The classroom is twice as long as it is wide. So you can see that in the diagram a little bit here. It's twice as long as it is wide. So this measurement is twice as long as this one. It measures 12 meters altogether. How long and how wide is the classroom? You're going to need to pause the video here and have a bit of a go at this. I would say, if you're not too sure, a good starting point would be a bit of trial and error. So you could try 1 meter and 2 meters, because that's one twice as long as the other. But does that get you to 12 meters in total? No, it doesn't. So have a bit of a trial and error there and see if you can get the answer to this one. Let's see how we can do it. So our width then is half of the length. So this is a bit like a bar diagram here. We know it's going to be 12 altogether. We've seen really, we've got kind of 3 blocks there, 1 for the width, 2 for the length, and that's showing that the length is twice as long as the width. So one thing we could do is divide 12 by 3. 12 divided by 3 is 4. So each of these little kind of blocks that we've imagined here would be worth 4. And so how long is that length altogether then? 8. 8 meters. So we've got 8 meters for the length and 4 meters for the width. Okay, I'm going to leave you to have a go at the questions now. Anywhere where it's talking about a classroom, clearly you'll need to adapt that a little bit so that it can be things at home, but have a go at this, have fun with it, and I'll see you back at the end for the answers. Okay, thanks everyone. I hope you've enjoyed that. You've got all your answers here and on the next page, so you can pause these and assess what you need. Okay, thanks everyone. I will see you back for our science session after this.